Well, I had 3 students asked exactly the same question. So I figured if 3 people have the same question, other people probably do too. So that's what does this mean, right? So the first thing you should note is that there are various issues that came up in assignment 1, and I took points off depending on how important the issue was. So if it wasn't too important, I took like a 1 point. And a little more important, 2 points. Really important, 5 or more. So this is a big deal, right? And so we need to understand what the issue is behind the deal, right? So several times I do the same diagram and put the same spot, right? When we talk about what an object is or what a class represents, we talk about, oh, it should represent an abstraction, right? It's a stack, right? What does the stack do? Oh, it's first in, last out, right? But that also implies those are the operations, what it does, but we also have data associated with it that it keeps track of, right? If we're in a language like Python or Ruby, we can create standalone functions, right? So if we have a class that just contains functions and there's no field of properties, it's like in Python and Ruby, we don't need those, right? You just create a file and you just type in the function. So why have this class thing around it and then you have to instantiate it and then like call it? It's like, no, just call the function directly, right? Then there's a flip side, right? Um, so if you just have functions, right? Just get rid of the class part. I mean, just throw it away. I mean, just erase this part and create a file with a bunch of functions, and it's going to be easier to use. You just call the functions. You don't say new thingamajig utility and then thingamajig utility dot this. You just say call foo and pass in the arguments, right? Now the flip side is just have data, right? No operation, right? And you have to step back and ask yourself, okay, before this object-oriented programming, we had things like C and Pascal and a bunch of other ones you've probably never heard of or been long forgotten. And there was data over here, and then there was method or functions over here, right? And so what was the big idea in object-oriented programming? Well, it's that we should take the data over here and group it with the functions over here that use that data, right? And then we can use that to form an abstraction, right? And now, why is this important, right? So where this came up is we've got a Q class, right? And it has a linked list inside, W linked list, right? Um, and so I need a node class, right? And so we have a node, and the node for data needs several things. all right? It's there to hold, it's a container, right? To hold some value. Right? And if you're in Python, it's values. In Java, then it has to have some sort of type, and then you get the generics and an angle bracket T, something, blah, blah, blah. But then we need basically next and previous, right? Now the value, it's just a container. The value is just there to hold it and get it back. So we never do anything with the value except hold it, right? You put it in there, and when the time comes, say, here it is. Here's your thing back, right? So now, what about next and previous? What do we do with them?
They are also kind of a pointing.
Yeah, so at some point I have, and since it's circular, I'll just not bother, right? And now let's say this is our tail, right? So now it's time to add a new node. What do we do? Oh, we have to create a new node, and you put some value in it, right? And now what we have to do is, previous has to go there, and the next has to go there. Oh, and we have to be careful about the order we do this in, right? But now this value now has to point here, and this value has to now point there, right? And so the operation that we perform with previous to next is to link it in to this chain. Now, where do we do that? Well, where everyone did it was in the Q class, right? And the reason I took the 5 points off is to say, look, we were talking about this, right? Data and operations go together, and well, let's say people had a Q class where they had operations and data, and then had node class, no operations, and then some people had utility class with just functions. And it's like, 2 out of 3 were not really classes, all right? They were just, one was just a structure and one was just a list of functions, right? Now, why is it important, right? Well, first of all, remember back when we started programming, they first told you about linked lists. It's like, and now your job is to implement a linked list, right? Y'all did this once, and how well did it go the first time? The first time you wrote a linked list, did it work right away the first time? No, it didn't, right? It got all messed up because you got the pointers wrong, right? Um, so what if we put in our node class, say, a method called append, right? And what does append do? It just does this, right? So when I say node A dot append B, right, and both are nodes, then in the node class we go, okay, the append goes link, right? And that's all it does, right? And now I can create 2 nodes, and I can append one to the other, make sure they're right, right? And then I could create 3. I could create a chain of 3 nodes, and then append a node somewhere and make sure it works, right? And now in the Q class, I don't have to worry about next and previous. I just say, okay, where does this node go? It goes right here. Oh, tail.append new node, right? And when we talked about, right, in object-oriented programming, the idea is information hiding. So we have things that we use but we don't have to worry about how they work, right? How does array list work in Java? We could add things and get them back, right? And we don't worry about how it works inside. And that's one of the things. Information hiding is like, okay, I just use it. Now, when we build our classes, right, there's going to be small little things. And if those small little things take care of their own data, then when we use them in slightly bigger things, then the bigger things, we don't have to worry about those details. But the small things are all structures or classes that don't have any operations, and the bigger class has to do all the work, right? And that means the person who writes the bigger class has to worry about all the details involved in the smaller classes, right? And again, you're all good enough, and the node class is simple enough, it wasn't a big deal to do it in the Q class, right? But that's not true in the real world, right? In the real world, you get complicated things, right? And so the goal then is when we create our classes, we want them to do some of the work. So then we can plug them in some other place to use them without having to worry with the details, right? And so then the node class can have like a particular sense of a doubly linked list. We can have an append and a remove, right? And then we can make sure that works. And then in the Q class, we can just use those operations. And then when we get our Q class working, we can then use that in a program and not worry about nodes and links and unlinks, right? It's a Q class and it's first in, first out, right? And then and the code that uses that, we can, if we do it right, then we can forget about all the fact that there's a queue in there and there's all that stuff. It's like, okay, no, we just use this public interface to get their job done. Right? So that was, and the reason I wrote struct is because you're using it like a structure, and I didn't want to write a paragraph for every one person, like, well, you know, this really is not an object word, they're operations.
So, is it wrong to say like my bigger class, the parent class, has to have this node, which is an inner class? I cannot have a struct inside a class. But if I create an inner class which has only data but not any operation, operation is in the class.
Well, so I'm talking about design, and you're talking about a language feature.
Yeah.
So my point is, when you design your code, why don't you have any operations in that small inner class, right? I'm not saying you should have used a structure here. My goal is to say, look, whenever you create a class, right, what are the responsibilities of that class, right? What are the operations and what data does it hold? And whenever we've got more than one class involved, there's always this who does what, right? How do we share responsibilities? And remember the Dilbert cartoon I showed, and everything I learned about programming, I learned from Dilbert. A lot of it was just like, well, you're going to have multiple classes. Who does what, right? And we don't want to have a bunch of smaller classes that don't do anything, then a larger class has to worry about all the details in all the smaller classes. Because at some point, it becomes too hard, right? That big class has too many details you have to know about and keep in your head, right? So, one of the goals of in programming is, I find the abstraction. Oh, it's a node. It doesn't do much, but it does a little bit. And now when I use it in a queue, I can forget those details, right? Oh, it's an address. Addresses are more complicated than we think because it's different. I mean, what's an address in India, right? And what's a valid address in India? Something different here, right? And in Japan, they're just numbers, right? It's like they just number the houses randomly when they were built. It's like, okay, you built over there, number one, you built over there, number two, and then someone's number three here, and four here, and five there, and seven over. I mean, like, it's crazy, but the different countries have different structures for addresses when it's valid. And so we create an address class, and then, okay, it was with all that sort of stuff. Now I can just use it. Need to print labels out? No problem. I just, address class knows how to produce the right thing, right? And all those details, someone had to worry about it. It may take a long time to get it for different countries and different regions, blah, blah, blah. But now it's done. I can forget about it and just use it. Now, of course, this is the ideal, right? And people point out leaky abstractions. Abstractions do leak information. For example, one student, there's a couple of students in their Q class to print things out or to sort them, right? They were using reflection, like, oh, we can use reflection and not have to pass in a string, and then so you just pass in the name of the field, the property or field you want to use to sort, and then we use that. But the problem is, of course, when you do that, reflection in Java creates all these weird exceptions. Invocation not found. And then what happens is, okay, when I call this sort function, I get this, I have to handle these weird exceptions. Okay, that's leaking information, right, about the abstraction to the outside world. And that happens a lot, but, our goal is to, keep data and operations together and encapsulate it so that we can forget some of these details, right? And then build upon that, use those building blocks and get bigger building blocks. Okay, any questions? Like I told one student, there's too many things in life to think about in detail everything, right? So we figure things out and then we just go with it, right? And we form habits. And so what happens is in program we do the same thing, right? We capture a certain amount of knowledge and this is how we do things. And I even came across someone who claimed that he would go to these programming contests and he claimed that programmers in the same company tend to score about the same level, sort of indicating that they all reached, they talk to each other and sort of reach a level, and they don't go beyond that because, well, you're as good as anyone or slightly better than everyone, right? So you're okay. And so my goal with assignment one is to sort of, force you to step back and say, okay, we need to think about these things, right? It's a design class. One student came and said, well, in assignment two, so we're going to turn electronically, right? And I go, no, why? He goes, how are we going to check the GUI? And it's like, it's a design class. My main goal is to see how you solve those design issues, right? And how good the GUI going to look. I mean, I don't care. I mean, the goal is to give you certain design problems, and then you solve them in code. And then we look at what happens. In the past, I've had students tell me when they take this class, it takes them longer to program. And my analogy is, yeah, if you do a sport, you play tennis or any sort of sport, and then you go to, improve your level, and you go to a tennis instructor, for example, and they say, oh, your form was a little off, and you have to make some changes to your form to do it right. I mean, your game gets worse, right? Because you have some bad habits or habits which aren't optimal, and then you have to break them to get them to better habits, and that takes a while for your body to adjust. In the meantime, you're like, ugh, you want to do this, but no, you're supposed to do that, right? Right? And sometimes you do this, and sometimes you forget, and then you remember, and then you're too late, and you miss it. And it's like, oh, but yeah, when you want to step back and improve yourself on any sort of skill level, usually, that's a painful process, and it takes a while, and again, there's oh, two data points. Many years now ago, I came across an article. Um, Someone wrote an article in some journal, and he said, "Yeah, everyone claims to be object-oriented programming, but I don't see it. I don't see anyone doing it." And he said he got a lot of people writing in and saying, "No, no, we do it, we do it, we do it, we do it," right? And so he then went to 9 companies and examined what they're doing, and he said, "Well, his end result was, we know all the 9 companies that claim to do an object-oriented programming, he only found one, right? The other company was just writing functions and putting them in classes and putting data in classes and sort of mixing them together." And um, another data point, like I said, years ago, well, not as many years ago, there was this annual object-oriented programming conference, and each year they got a theme, and one year the theme was, has object-oriented programming failed? Um, this is probably 6, 7 years ago, and of course the answer was, of course, it's not failed, but it's a recognition that people are not seeing the benefits that were claimed for object-oriented programming in the beginning, right? And the question is, why is that happening? Why aren't we seeing um, all these great benefits? And there's this famous book called The Mythical Man Month. If you haven't read it, you should. It's very entertaining, um, and it's very insightful. But in that book, he claimed, yeah, one of the possible silver bullets for the problems he was describing, he thought, was object-oriented programming. And the question is, why isn't software, development improved greatly since everyone else supposedly is doing object-oriented programming? And part of the answer to the conference was, well, because just because you're using Java does not mean you're really doing object-oriented programming. So any questions? Okay, let's then move on. So last time, well, a week ago, we are talking about iterators, right? And it's a pretty standard, um, basically almost all modern languages have collections, and all modern, right, um, languages and their collection classes give you iterators. And so the iterator, I should have left the screen up and seen how long it took someone to say, hey, by the way, you forgot to put the screen down. Right, so we got, a collection, and again, give it as an interface, right? Because there might be different types of collections. And that's why, the other thing people ask about, why in your Q class did I say parent minus 2? It's because what should the parent have been to that Q class? In Java, you want it to be, there's a Q interface, there's also a collection interface. If you make that your parent, then your class can be interchangeable with the other classes, right? And becomes more useful. Then there's iterator, which has, various methods. Again, an interface, and there's a concrete iterator. Because again, we don't want people to know that there's an array list iterator which may behave differently or have different methods than a linked list iterator, because we want them to be interchangeable. And then you've got a concrete aggregate or collection class that actually gives you the concrete iterator. And now I can they talk about different types of iterators. Concrete, where you actually instantiate the iterator itself. And so in Java, we've got a string reader, allows us to iterate over the elements in a string. Polymorphic, where again, we don't know the concrete type. We get an array list, give me the iterator. What type do I get? Well, the method says it returns an iterator type. And so we really don't see what the concrete type is, because we don't want the people to know. So we don't have to worry about hard coding. Oh, it's an array list iterator, and then when I change to a linked list, now I have to go back and change all the iterator interfaces because they're different types. And then who actually controls iterating over all the elements? So in Java, right, the basic iterator has next, and so the caller is controlling when we go to the next thing, right? And we can do a bunch of stuff, then if we want to come back later, we can, or we can just say, okay, I found what I want, I'm done. These are often called external or active. Internal iterators, you basically usually say, hand it a lambda, and then it evaluates the lambda and all the elements in the collection. And so here's an example from Smalltalk, not Smalltalk, Ruby, where you basically are finding, get a collection, and then you say I want all the even elements, right? And so it evaluates that lambda on each element in the collection and only returns the one that returns true, that evaluates it true, and so we get all the even elements. We don't have to worry about has next and are we at the end yet or not. We just say, here's what, evaluate this and give me the results. I much prefer the latter to the former, because it's slightly higher level. Most of the time, I don't care about how many things are in there. Just find the maximum, find the sum, do this. And so you just iterate through them all and let the iterator worry about the details. If we've got a linked list, then it's pretty straightforward. But if it's a search tree, a binary search tree, and you iterate over that, then which order do you traverse the tree in, right? So we could either do that in an iterator. Iterator keeps track of, I want to, go depth first or breadth first, or we could have the object do it. It's usually easier to do it in the object, but then you've hard-coded it one way. So if it's a binary search tree and you want different iterators for different types of traversals, right? You want to do it, have the iterator define where to go next. Anyone know what happens here in Java? What's that? Yeah, you get an exception. And why do you get an exception? The problem is the iterator's keeping track of where you are, right? Now, if you modify the list, you could you remove the element it's pointing to. Now, what's the correct answer for the next element? Or you could remove the next element, right? And now, should I give you the next element that used to be there, or should I give you the new next element? Or maybe I delete half the list, and the iterator was pointing in the middle of that part I just removed. So what's the appropriate action to take then, right? And the problem is it's hard to figure out what that action should be, and so it's just easier to tell, look, don't modify this list, right? Now the real fun question is how do you implement that?
You have to have using Java classes. You have pointers or space class. You kept like a counter of updates. The iterator looking.
Right. So what we're saying is there's a counter, right? And so the collection class keeps track of how many times it's changed, right? And when you create the iterator, it gets a copy of that, so it knows how many changes were made before it was created, which means every time you add or remove an element from a collection, it gives that counter, right? And then every time the iterator says, call that method, it first check to see what its change count is compared to the change count in the collection. If they're different, raise an exception. At least in the Java world, they finally caught up. How many people here don't know about Java streams? Well, so I can create, a collection, and then I put it into a list, and I create a stream out of the word list, and then I can call filter on it. Which basically says, find all words which are longer than 2 characters long, and then, find all the words that are longer than 2 characters. I only want ones that start with letter A. And then I want to change it to all uppercase. And now collect the result. And then when I print it out, well, I didn't put the answer, but the way to implement it, we can do all this with one pass through the collection. We don't have to make multiple passes. We don't first do find all words of length greater than 2, and then go through that and we basically apply all the operators on the first word and the second word, third word, etc. So if you're a Python programmer or Ruby programmer, this is pretty standard, straightforward. You've done this, you should be doing this all the time. Finally, Java programmers can do it. It allows you to do, transform data in a fairly compact way. And there's a bunch of different methods they have. And yeah, there's various, by now there's tons of online things to tell you about streams in Java. And these types of operations are very common in the functional world. Okay. And Ruby is like, they've got lots of these, right? Each, collect, find all, any, detect. Python has a bunch. I don't think yeah. If you really want to know and see a good collection of these types of higher order functions, you should look at Smalltalk. They've got way, way more than Ruby does. But these are very common these days, and you'll see it in most functional programming languages have this. If you do Spark, Spark will have them. And I think I'll skip the rest and go on to something slightly more relevant to your upcoming assignment. Oh, I forgot. Yes, I will. I'll come back to the command later. I want to go, not command processor. I don't know about that yet. We'll see. I want to talk about the interpreter pattern first. The basic problem is I have a small little language and I want to evaluate that language in a program. How do I do that without writing a compiler? Right? And at first, this problem seems like it'd be pretty obscure and most people won't come across it. Unfortunately, that's not the case. Every time you've got a file, if there's any structure in that file, right, then you have to parse that file, right? And if the structure is sort of like a little language, I can write in that file. And so I need to write a small little parser for that. So people write parsers far more commonly than you think, but they don't call them necessarily parsers, right? I'm just reading a file. And so interpreter pattern talks about how we can write an interpreter for these languages. And so, right, given a language, define representation for its grammar, along with interpret a user representation to interpret sentences in that language, right? Yeah. Oh, I forgot. Oh no. Yeah, I've been converting all my lecture notes from having a black background and a white text to white background and black text, and sometimes the conversion doesn't work right. So if I got a grammar right, and the grammar rule says R is R1 and R2 and R3, then what we're going to do is we're going to build a tree. And the tree has at the root R, and then it's going to have a branch for R1, R2, and R3. Meaning, okay, if I want to execute R, I have to first execute R1 and R2 and R3, because that's what R is, right? So a simple example, are Boolean expressions, right? Ands and ors. So I have this Boolean expression, press parentheses, there's ands and ors and nots, right? And so here's my grammar, right? A Boolean expression contains a variable, a constant, an or, an and, a not, or another Boolean expression, right? And an and is parenthesis, Boolean expression, and Boolean expression. And an or is just parenthesis, Boolean expression, or Boolean expression. And not is just not, and then Boolean expression. And then constants are either just true or false. And a variable is some sort of string, right? Again, the lines connecting up the tree are gone. But there's a little expression, right? True or x or w and x, right? So that's a expression in the language of Boolean expressions. And then we can build a tree, right? So the top order operator is the or, and then we have on one side another or and an and then this or, there is a true and x, and has a w, and there's a typo that should be an x, right? And now to evaluate this, what do we do? Well, I got true and x, and so what does or do? Or does, okay, since that's true, then this subtree is going to be true, and and if w and x, if x is true and w is false, then this is going to be false, right? And now we go up to the top node, and we then have an or, and one side is true and one side is false, so we get true, right? So the whole idea is, okay, I take my grammar, and the grammar tells me what the tree looks like, right? Each rule says, here it is. And now when I have my expression, I then take each part of the language and convert it to a tree and build, a huge tree. And once I've done that, now I can evaluate the tree to evaluate that expression. And there are several key things. When I've got variables, I have to look at, I need some way of looking at the current value of the variables, right? And now, how do we do this in code? Well, we create an OR class, right? And the OR class has a left and a right. And what the OR class does is it first evaluates this left subtree, evaluates this right subtree, and look at the two values and say, okay, if one is true, I return true, otherwise I return false, right? So that's my OR class, and then I have to build an AND class. And again, an AND class has to have a left and a right subtree. And to evaluate the AND, you first evaluate the two subtrees, get the results, and say, okay, if they're both true, then I return true, otherwise I return false, right? And then there's not. Okay, not easy. It only has one subtree. And so to evaluate the not node, you first evaluate its subtree and look at the result and negate it, right? If it's true, return false. If it's false, return true. And so the interpreter pattern says, look, when you write down the grammar for this little language, right, the grammar rules tell you what classes you need, and it tells you how those classes should operate. And so an example here, it's like I create an interface, so my classes into that interface. And here's my and, right? And to evaluate it, what do? Is I evaluate the left operand and evaluate the right operand, and then I AND them together and return a result. And then I need some way to look up the value of the variables, right? And that's what the context is for. It's like, okay, I can then assign values to all the variables. I pass in the context. So when I get down to the leaf nodes where it might be a variable, it can look up its current value in my context. Simple enough.
Which has a class.
Which one? The
add. Double add.
Oh, this one?
Yeah.
No, that's an operator in Java. No, no, no. That's a good question. And the question is, what's the difference between the composite pattern and this one? This pattern is an instance of the composite pattern, but the problem it solves is very specific, right? And then the constants, I mean, what's the constant? Well, there's a true constant and a false constant, right? That's easy. And a variable, like I said, it has to look up its current value, right? So we can pass that in the context, and I can make a context basically some sort of dictionary lookup or some whatever you want, right? And again, it's like we don't care. I mean, again, we have the constant class or the context class of it. It does what we need to do, and then we forget about is it a dictionary inside or is it just a list? Right? We don't care. It's like, okay, it does what we need, and so forget those details. And here I just created a hash table, but there are various other ways of doing it. Then that expression becomes running this program. Right? And they talk about, well, easy to change or extend the grammar. If you want to extend the grammar by another rule, what do you do? That rule represents another class we create, right? Another class. Implementing the grammar is easy because the grammar says, R is equal to this and this, and so we build a class to do that. When the grammar gets really complicated, you can have all kinds of classes, and so you want to use a different type of system, right? Build a smaller compiler to do it. And yeah, we can actually use another pattern to find different ways to actually evaluate the same expression. When we look at the composite pattern, we'll see example of how to do that. If the language is small enough and simple enough, you can probably just do it directly. It's a matter of scale, right? It depends upon, if it's small enough, you can do it directly. If it's bigger, then you can do a interpreter pattern. If it's way too big, then you want to use something else. the biggest issue here is the pattern doesn't talk about how you actually parse, in our case, that Boolean expression into the tree, right? It just talks about how you represent that tree as a syntax tree and how you evaluate it, but it doesn't tell you how you go from here's a Boolean expression to building the tree. We haven't talked about these other patterns yet, so it don't make much sense. But yeah, so for a lot of different symbols, if it's a big tree, we can represent them as flyweights. That's our syntax tree. We build this instance of the composite pattern. And if you need to go through the tree, we can use an iterator if we want. Or you can just build it into the structure itself, not worry about it. Right, so that's just the interpreter pattern. Now I want to go back and see if I can make anyone sick. I want to talk about undo. So of course, the reason I want to talk about interpreter patterns is because I asked you to you might want to use that in your second assignment. I also want you to support undo, right? And you've all used undo countless times, right? The question is how to write a program to support undo. And there are two patterns we'll talk about that support undo. This one's easy to undo because it incrementing and decrementing, right? So you have to keep track of did you up or down, right? This one gets more interesting because if I do this change, right? If I change a word, then I have to remember the location of the word and what the word used to be, right? Otherwise, I can't undo it. I need to know where it was changed and what it used to be. Whereas in the previous example, I just need to know plus or minus one, right? So I just keep track of plus one, minus one, and I do that, and then just go backwards, right? Here I need more information. Now there's sometimes where like plus adding has an inverse, right? Subtraction has inverse adding. But sometimes there isn't a inverse, like adding, modifying a word. There's no inverse operation. I have to keep track of what it was and how to get back to it. Once we've got undo, then we get redo, right? Oh, I really. And then, how far can we go back? And then it's like, oh, then we can intermix going back and then going forward multiple times, right? And how to keep all that straight. Like I said, there's two patterns we can use support on in design pattern Goff book that talk about undo. The first one of them is called Memento. And the goal is pretty simple, right? The job of the Memento is to store the internal state of an object so that internal state can be restored later. Now, I'm talking about Memento pattern in the context of undo, but there are other times we may want to use this pattern. Another common place is if you've got a long-running program, say the program runs for, I don't know, 7 days. Well, let's say to make it worse, it runs for 3 weeks, right? And then at the end of the second week, it crashes. Or the computer crashes, right? Or, as once happened on campus, the janitor walks in the machine room and needs to vacuum it up and can't find a open outlet, and so they temporarily unplug one computer, which happens to be the main computer for the entire campus. Um, you just lost 2 weeks of computation, right? So one common thing to do when you have a long-running computation is you take snapshots, right? So that if something goes wrong, you can then, when you start the program up, you can start it from a snapshot rather than have to rerun those entire 2 weeks or 2 months or however long it was running. Now, another side comment I have to make is, like I said before, when we talk about the roles that are in the pattern, some of them are just roles, and you're not going to see classes with those names, right? The originator just means that's the object we want to save the state of, right? And so we're never going to see, you should never see a class called originator because, no, it's some object that we want to save the state, right? And why call the originator when we're writing a program for some purpose, and that the class name should reflect what that class does, not the role it's going to play in an assignment to implement the Memento pattern. So it's just whatever class we want to say that state. And then Memento is just basically a container that holds the state of that object. And then we need some place to store it, right? So we can get back to it later. Now, how we store it depends upon what we're trying to do, right? If we're taking snapshots of the program, we'll just probably store it in a file, right? We'll label a file by date, right? Or time, date, stamp, so we know if we need them, we can know where to look and find it. And then the other part is not just saving the state and restoring it, is how do we maintain the information hiding, right? That we don't use a memento to sneak the data out of the object and so I can play with it. And so there's some sort of originator. We had 2 methods. One is create memento, so it takes the state it needs to save, puts it inside a memento, and hands the memento to us, and we can store it someplace. And then there's a set memento where I can give, here's your memento, and you can then, the originator then takes the data out of the memento and restores the state. And then by encapsulation, we can do things like, we can, in Java, we got some tricks we can play. We can memento an inner class, and so it has access to the fields, and then we can basically make the memento so that it doesn't all data is private, so no one can get to it. But the goal is, so we only want the originator to have access to the data inside the memento. Right? I think you'll find, most of the patterns, the basic idea is pretty simple, right? Pretty direct. That doesn't necessarily mean that they're easy to implement. Of course, one thing that's hidden here is what sort of state are we saving? right? If the state is just strings and ints and floats and doubles, right, the base type in your language, it's pretty straightforward. But what if the state of your object contains other objects, right? And those objects contain other objects, right? Now what do we do? So here's a silly example where, I just created a Memento to be a hash table, but then my originator can just say, name my field value, name my field value, right? And I just do that, right? Name, state name, object, and then, some complex object. So I create a memento and then I set all my states. Um, but, so there's some object of state. And so what do I do here? Well, yeah, now the issue is, what do we do with objects, right? Before I get to that, yes, you'll be tempted to do this. And there are times when this might be appropriate, but the pattern says, okay, there's some sort of caretaker somewhere that keeps track of the state. And one temptation is, well, I'll just create a stack inside my object, and then every time you say save state, I put all the state in there, right? The problem with this is, what happens if your program has, I don't know, say 10 or more objects of different classes, and you're tracking undos in each one? Now the problem is, if each object is keeping track of its own state changes, when you want to do undo, which one do you undo first? Well, you undo the one that changed last, but which one was that? Well, each individual object are not going to know which one of those objects changed last, right? Because they don't know about the other objects. And so that's one reason why they don't have each object keep track of its changes. You need some global place to know the order in which changes are made. Also, another problem is, this means every time this object changes, you have to save the state. And what happens if you are using this same class in a place where you don't need to support undo? Well, the object automatically is saving the state every time you change, right? Because it's built into the object. And what happens now if, I don't know, let's say you've got a Q class, right? And you're keeping track of all the changes all the time the process is added or removed. Oh, and it's been used by an operating system. Well, I don't know, that's running in some closet somewhere that people are banging on because it's doing all kinds of, I don't know, it's one Amazon servers, right? To service all their web pages or something. And so it's getting hit thousands of times a second, and you're creating processes all the time. And every time you create a process to put it in the queue so the operator can keep track of what's going on, you're saving the states. And every time a process leaves, you're saving the states. Oh, how big do you think that stack will become after, I don't know, say a month? How much memory you can consume when you don't need it at all, right? And so there's various reasons why they don't have the object keep track of its history. So it's expensive. Yeah, it's expensive memory because every time you make a change, you're copying everything, or maybe you're copying just parts of things. But yeah, I mean, you're still copying. Takes space. Um, yeah, these narrow and wide interfaces, so that the outside world is very narrow, but you can't do anything in Memento except hold it and give it back, right? Um, so we have, here is C++, but you're making, how do we keep track of making it? Um, the outside world can't access it. Well, in C++, we can make it a friend, and in Java, we can make it an inner class, right? Make it private. Then you return this object, but no one else can do anything with it. Um, yeah, we can, clone things. In Java, right? We got this clone interface. Um, the complication here is, what does cloning do to sub-objects? Right, again, I got an object which has fields, which are objects, and those objects have other objects and fields. And what do you want? What do we want to have happened, right? Do we want to make an entire clone of everything? But if we're tracking changes, we'd be better, right? Because otherwise, one of the subset objects may have changed, and if we don't keep a copy, then, or maybe, well, are those changes being tracked separately or not, right? Yep. Well, um, there's shallow versus deep copy. Um, right. So shallow copy just copies the first level, um, right? And then they still point, second level still points, copy the door, but they still point to various, um, and deep copy, well, a deep copy will, here I'm copying the door, and then each door has a room, so I copy that, but then the third level down, right? And then I can just copy all the way. And I once had a student who said, yeah, our company we've got shallow copy and deeper copy and a really deep copy. And I mean, literally, they had, they had so many versions, right? No one could figure out, in this case, which one do I want to use? Because, I got to go down 2 levels, 3 levels, and so they put another one. And so it was a mess. It's like, well, no one really knew what was going on because there's like 5 or 6 different levels of copying and cloning. And in C++, we have, we can create copy constructors to do it for us. Um, and then we have to worry about how far do we want to copy things down. And so yeah, another place where you might want to use Memento is um, doing experiments, right? You have some sort of planning software and say, okay, I want to try this scenario. Okay, I don't like that. I want to go back to where I was, right, and change it, right? Um, it's like Excel, you're doing budget planning, right? Okay, let me see if we try this out. Okay, now I don't like that answer, so let's go back here. How do I get back here, right? Um, and so that's another place where we want to um, and one property that you see in functional programming is you want your data to be immutable. Um, and that makes the mental pattern a little more interesting because, okay, whenever I want to change it, I mean, you create a new copy, and so you already have the old copy, right? Um, and there is a database called Diatomic, which comes from the people who created Clojure. And this database, there's no way to change data in the database. When you insert a value into a row, you cannot remove it. And the reason is they say, look, there are lots of situations where you need that history, right? When we think of banking, right? You can't lose track of the history, right? You need to know everything that happened, right? It's not like your bank account has a current balance and they forgot about how you got there, right? And you go online, it's like, here's all your transactions for the last 10 years, and they need all that information, right? And it happens to me a lot like, well, what did we do last year with this information? Well, it's gone because we only store the current value, right? And so it's transactions become easy because you don't have to worry about locking rows because they're all locked, right? Automatically, you can do reads and writes independently, right? You don't have to worry about when I do a write, I don't have to lock the database down. I can just read and write. And so literally you can do interesting things where um, they're completely independent and they can even be on different machines, right? Um, you need to roll back the database if something went wrong, no problem because you've got everything is historical, all historical data is there. Um, and yeah, you want to audit what happened? So we got that. Of course, now you want to be space efficient too, and there's probably a way of at some point pruning because Amazon probably, well, actually, they probably keep track of every transaction they've ever done, right? Um, because you can always go back and see all your past orders, right? Um, and they're continually reminding you, oh, you bought this. It's time you buy it again. Um, and if they can keep all that information, then okay. So next time we'll look at the command pattern, which is another pattern which supports undo. Oh, it also has other uses besides undo.